Testing 1, 2, 3. Okay, guys and girls. So I would like to discuss regards on set practice here today. So let us begin the discussions here on this set practice here. Let's see section A, question number 1, 9 marks given. Regards on chapter 8. You are given limit x approach to negative infinity for hx squared plus kx, mx squared plus k equals to 6. Limit x approach to negative infinity, kx plus h over mx plus k equals to 2 over 3, where the h, k, and m all are real number. And now, A, we would like to have h and k written in terms of m respectively, which means that in this part A here, we would like to have m written into some function that is do with m. For example, let's say a function do with m, and then k also some function do with m. Then hence, based on this result here, we would like to find out what is the following limits below accordingly. And let's see how we solve for these questions here with the info that we have. Let us begin with part A first. So, according to the questions, this limits is equals to 6. And if we try to do direct substitutions into the functions top and bottom, we'll find out that it will give us the result of infinity over infinity. And by the time we have infinity over infinity in the limits, what we're trying to do so that we have some real number solution is that we will divide with the highest power of denominator. In here is x squared. So we're going to divide this function here with x squared over x squared. And then we try to simplify. From there, we try to look for a way that we can represent our h or k in terms of m. So this is what we try to do for the first part of the informations. For the second part of the information, again, if you try to do direct substitution inside, you find out that you have, again, infinity over infinity. And this time is the case of negative infinity over negative infinity lah. And the result is supposed to be a real number. So once again, this case here can be reduced to avoid the situation of infinity or infinity. And the strategy we're going to do here is we're going to divide with the highest power of the denominator, which is the x term here. So we're going to divide x top and bottom. And from there, maybe we can do some adjustment to get our solution of A, where we write h and k in terms of m respectively. So now let us try to go on with our solutions here, where I start with the limits x approach to negative infinity, hx squared plus kx over mx squared plus k equals to 6. So as you say just now, we would like to consider dividing x squared top and bottom on this term here. The divisions, we don't have to write it down like here, like this one in red here, but you just need to show the appropriate result we do. When the function divide by x squared for top, each of the term on top, each of the term at the bottom, what we find out for the result is that we have it as h plus k over x on top. Below I have m plus k over x squared. And this result we already know according to question equals to 6. Then from here, what we proceed further is that by right the moment and bottom, I can avoid having the situations of indeterminate infinity or infinity. So at this moment here, I suppose I can do direct substitution on these two positions here, where we notice that k is actually a constant. And when the time I have the case of divided by infinity, no matter it's plus or minus infinity, the result is always happen to be 0. So therefore, I can have the result now written as h plus 0 on top divided by m plus 0 below equals to 6. And now we can have the answer m in terms, h in terms of m written easily as h equals to 6m, where this is actually equivalent to h over m equals to 6. So rearrange the m, we have the answer h in terms of m now. So h is equals to 6m. Now, do the same thing for the other one. So this time, the information is approach to negative infinity, kx plus h, mx plus k, and the result is equals to 2 over 3. So in this case here, once again, like we mentioned just now, the strategy is that we're going to divide x top and bottom for each of the terms here. And I suppose I have my result as following, and it is equals to 2 over 3. Direct substitution of infinity inside these two bracket terms here is supposed to give us 0. So I have k plus 0, m plus 0 equals to 2 over 3. Then from here, it's supposed that you know that this is k over m equals to 2 over 3. So therefore, write k in terms of m, I have the answer k is equals to 2 over 3m. Now we have done the first part to get the answer of h and also k. After we get the result of h and also k, according to the questions, they say hence find the following limits. So hence make use of previous result. So the previous result we have in order to solve part B is that we would like to make use of these figures here that we find out h equals to 6m and k equals to 2 over 3m to solve the following questions. So in this way of solving here, what we can do is that we can try to replace each of the terms come with h and also k here correspondingly with 6m and 2 over 3m. Then from there, we try to solve for the answer. And however, in these calculations here, I doesn't directly solve the k and also h in terms of m inside these functions here, because I see a 2 over 3, it seems to be a fraction inside a fraction later. By the time I do substitution, it may make the whole situation looks complicated. So let me think of some other alternative methods where we don't directly substitute the m. Maybe we don't directly substitute the m, but instead what we can do is that we just continue from here directly to do further calculation and simplify. So we find out that if I do direct substitution of negative infinity inside for calculations, it will supposed to give me the answer again, infinity over infinity. So in order to avoid this indeterminate form, I will again divide top and bottoms here with the same term, which is the highest power of the denominator, x squared top and bottom. And for information, the coefficient k, we don't have to consider in the divisions. We just take the x squared divide top and bottom. And then from there, we try to simplify our answer to look for clue to solve the questions. And therefore, I find out from this, if I divide top and bottom with x squared, I will find out that the result for the function, the limit notation is still there. I have h plus m over x plus k over x squared for the top part. For the bottom, I have it as k, h over x, m over x squared. And in here, if you realize, I put brackets on this smaller fraction here so that our writing here will be clearer to see which one is larger and smaller fractions. Then now, at this moment here, if I go on with direct substitutions, I find out that all this position here with brackets here, it will give us the result constant over infinity, whether it's plus or minus infinity. Therefore, I have it substitute as 0. So as a result, I have h over k. The result of this limit is h over k. And now finally, we make use of the previous result that we know about h and k, which is written in terms of n, which is h is 6m, k is 2 over 3m. So let us substitute accordingly in terms of m. Then we simplify our answer. The m and m can cancel. 6 divided by 2 over 3, we have the answer equals to 9. There goes the result for the solutions here for these questions. Number 1 in section A. Go on. Next, we have section A, question number 2. These questions here allocate for 9 marks, and it is going to test us on the knowledge on chapter 9, which is differentiations. And let's see what happened in the questions here is that you was told that fx is equal to the, the, the piecewise function defined in the way of 2 minus x and x squared plus 3 for x less than minus 1, x greater equals to minus 1. And you was told that fx is continuous at x equals to minus 1. Now, with this information here, they ask us to show that f minus 1 is equals to 4. And how we get the answer, we just try to decide in this piecewise function, where is the position that I have x equals to minus 1, I plug inside for calculation will do. And then next, part B, determine whether f is differentiable or not at x equals to 1. So what is the thing that we need to do is that we want to test the differentiability at the point of x equals to minus 1. So which is, in other words, we want to find out these limits here according to the differentiability limits. X approach to minus 1 for the function of fx minus f minus 1 over x minus minus 1. Does this limits here exist or not? If exists, differentiable. If does not exist, not differentiable. And of course, the existence of these limits here is also can provide us the reasoning whether why is it differentiable or not differentiable. So how we use this idea here to go for further calculation in part B, later we will see in the solution. Now let us focus on the calculations on part A first. So part A, if I want to show that f minus 1 equals to 4, what I do is that first, what is f minus 1 is actually substitute x equals to minus 1 into the function. And where is x equals to minus 1 according to the function here? So you find out that it will actually located in the second functions. The minus 1 is actually located in the second function. As you see, x equal to minus 1 is in the second function. So we just need to substitute the x minus 1 into the second functions to get f minus 1. So as a result, we have minus 1 squared plus 3, and this result is equals to 4. And from here, we can easily done our proving. We have shown f minus 1 equals to 4. Once we get this answer here, next, what we need to do is that we want to determine whether, as we say just now, whether this limits here, as I mentioned earlier, does this limits here happen to exist or not? So in order to know the existence of limit, so I need to consider for the same function, limit approach to 1 minus the left-hand side limit, and limit x approach to 1 plus. Do they have the same value or not? And in this calculation here, important remark to take notes, where the value of f minus 1, you don't have to repeat the calculation and substitute the minus 1 accordingly for whichever function for minus 1 minus or 1 plus. It is always stick to the value that we have calculated just now, where this value here minus f minus 1 is a constant based on the knowledge on our calculations in the chapters of limits, where we see where is this exact value x equals to minus 1 located, and then we calculate the corresponding function value as we do in part A just now. So please don't you ever have a misunderstanding thought that if let's say I have minus 1 minus, when the time you calculate f minus 1, then you choose the case of minus 1 minus function, then the other one, 1 minus 1 plus, then you choose for minus 1 plus functions for further calculating. It doesn't happen in that way. It's a constant that we able to calculate earlier and we just plug in. And in this case here, they get us to find out the value first. So now proceed with our calculations. In order to do these calculations here, I need to decide in the limits there whether what are the fx I'm going to use. The rest of them is actually the same. It's just that the fx will change according to the left hand side and the right hand side limit. And let's just see how can we get the answer here. So let us first identify For left-hand limit and right-hand limit, which function we are using? So we have x approach to -1 minus. We are going to use the functions 2 minus 2x because this is located at this interval, slightly less than -1, which is less than -1. X approach to -1 plus, slightly greater than -1 is referred to the second functions. And now we start to calculate our limits. And watch out for the limits is limit x approach to -1 minus. I start with the left-hand limit for the calculation of function fx minus f minus 1 over x minus -1. So this is by the idea for the differentiability formula. And in this case here, we calculate for the left-hand side limit. So we substitute the appropriate functions in this case here. For the case of -1 minus, I'm using the fx as 2 minus 2x. So I substitute this fx here as well as later replace f minus 1 with 4 as we calculated in part A. Simplify the x minus -1. So I have the following result. So again, we try to check. Substitute the fx according to -1 minus. Substitute f minus 1 as we calculated in part A. Then lastly, simplify the denominator. And reach up to this moment here, what we do proceed is that let us simplify the function on top. We find out that we have answer -2x minus 2. Reach up to this moment here, after we finish simplifying, let us try to do direct substitutions into the functions and try to see do we able to get a real number answer to get the final solutions. So you find out that when the time I substitute -1 inside, when the time we substitute x equals to -1 inside, so we have the result as 0 over 0. So this is an indeterminate form where we need to find out what are the factors that creating 0 and we want to cancel it. And in order to do that, we need to factorize the top parts. Factorize -2. Now we can see the one that creating 0 top and bottom is x plus 1. The same term top and bottom. So if we do cancellation on it, we have the function now turn out to become a constant 2. You need not show me the cancellation, the crossing of the cancellation, but you just need to show me the result after the cancellation. And then by the properties of limits, limits of a constant will be equal to the constant itself. So we have answered -2. So the left-hand limit, we have -2. Now we try to have the right-hand limits. The right-hand limit x approach to -1 plus, the function will be fx minus f minus 1 over x minus -1. And now for the function of fx, for the case of right-hand side limit, I should be using the second function, which is x squared plus 3. So I'm going to substitute this function fx again. Substitute also f minus 1 according to the result in part A. And also simplify the denominator. It should give me the following result. So again, we check the change of functions for -1 plus. Substitution of f minus 1. Simplify denominator. So then once again, we simplify our function on the numerators. Positive 3 minus 4, I have -1. So in this case here, direct substitutions of x minus 1 inside, again, it gives us 0 over 0. So we need to find out which are the factor that creating 0. We factorize the quadratics. And we can see that we can cancel off the x plus 1 to get function x minus 1. Substitute -1 into the functions here. I will have -1 minus 1. Finally, I have the answer -2. So I find out that both of the limits from left from the right give us the same answer, which is -2. And therefore, we find out that from here, we find out that the limit x approach to -1 minus fx minus f minus 1 over x minus minus 1 exists. If this limit exists, means that what? The function f is differentiable at the point of x equals to minus 1. So the conclusion is that the function is differentiable at x equals to minus 1. And the reason, we say that we find out that the two limit from the left and from the right is equals to minus 2. Then we go for conclusion. So here, this is the reason. Of course, if you want to further emphasize to say that limit x approach to minus 1 plus fx minus f1 over x minus minus 1 exists pun tak ada masalah. But important conclusion to say is that you must mention is differentiable at x equals to minus 1, because this is the final conclusion that we want to make decisions. So there goes the solutions for question number 2 in section A. And now we go on with the answer for the next questions. Section A, questions number 3. This one is regards on chapter 10, the application of differentiations. They ask us to find all the critical numbers of the function fx, where the functions is equal to 2 bracket x power 3 plus 1 power 1 over 3. So what they actually asking for this case here is that what is critical number? So for your informations, in lecture, we do learn some term called as critical point. So if let's say a critical point for the function of fx, it is actually referred to the situations where we have the two scenario, where the first scenario is when the time we have the first derivative is equal to 0. This is what we commonly see. This is also the case that we have stationary point, to be specific, for the critical point. The other case, we have the case that f prime is undefined. So this is what we learn about critical point. What is critical number again? So for information, critical point, we have x coordinate, we have y coordinates. The critical points, if let's say is given by the coordinate xy, so the x will refer to what we call as the critical number, and the y will refer as the critical value. So the critical number means that we want to find the x coordinates of the critical point. So as a result, what you need to do is that you need to begin your solution by finding the first derivative. So therefore, we find out our first derivative by using power rules. Quick recall on how we do the calculation for power rules. If let's say you differentiate with respect to x for a function hashtag power of n by power rules, the result you have is that bring the power to the front, multiply with the brackets, the n reduced to 1, and then multiply with the differentiations of the hashtag. So this is a framework for applying power rules. So now watch out. The bracket terms here is the hashtag. So by power rules, I will bring 1 over 3 multiplied to the front. So I get 2 over 3 in front. The bracket terms maintain, but the power reduced by 1. So I have 1 over 3 minus 1, get negative 2 over 3. And it's not end of the story yet, because I need to differentiate the bracket terms here. So x power 3 plus 1, differentiate, we get 3x squared. And this whole thing here, you find out that we can simplify the constant 3. Therefore, I have 2 multiplied with x squared. And this whole bracket terms here with power of negative, it can be written in the form of reciprocal, which is I have 2x squared over x cubed plus 1 to the power of 2 over 3. So this is the answer that we have. Of course, you can always convert it into a root form if you want to. But in here, I just convert in the form of index with power of 2 over 3 in the denominator. It should be good enough. Now we will proceed further to determine what is the answer for the critical number, which is the x coordinates of the critical point, by using um, f prime equal to 0 and also f prime is undefined. So from here, we start with first, when is the time that we have f prime is undefined. By right, this one, we can get the answer just by inspection. But just for the sake of having even a better idea, we do some calculation there where this function f prime here is undefined only when the time the denominator is equal to 0, is equal to 0. So you find out that it will only equal to 0 when the time x cubed plus 1 is equal to 0. And from there, x cubed is equals to minus 1. So use your calculator to get x value by having x equals to the cube root of -1 using calculator. You find out that the answer is -1. So this is one of the critical number happen when the time f prime is undefined. And of course, one important thing to take notes are this x value here, it is undefined in f prime. However, it is defined in function of f. Or in other words, this value here is inside the domain of f. Then only is a valid critical number. If this value is not even inside the domain of f, then it's nonsense. Then of course, in these functions here, you find out that this function actually is defined for all real number. Go on. Then next, we would like to find out what is the case if let's say I have f prime equal to 0. So substitute the f prime equals to 0. What we find out is that if we try to simplify our answer, multiply these terms here to the other side with 0. So I left with 2x squared equal to 0. Therefore, x is equal to 0. And this is another critical numbers that I should have. And of course, once again, double confirm whether this x value is it within the domain of f or not. Then only we come to conclusion to tell that these two are the critical numbers, which is the x coordinate of the critical point. So there goes the answer we have for this section A, question number 3. Okay, then now we proceed with section B, question number 1. 5 marks is allocated for the questions on complex number. So in these calculations here for complex number, one important things that I want you to be aware, alert on solving this question here is that whenever you have the case of square root of, let's say, I have a negative number. For example, I have the case like a -7. You must always convert square root of negative number into I form first, where this one and actually written as square root of -1 multiplied with square root of 7, which convert the square root of -1 here become I multiply square root of 7. It's important to take notes. Make sure you always convert the square root of negative number into I form before you proceed for your calculations. So, therefore, given the conjugate of z is following, find the x and y value if z is x plus yi. So the z is given, and please alert lah, be alert. Inside the equation here, this is conjugate of z. This is conjugate of z, which means that this conjugate of z is actually x plus yi become x minus yi. We change the sign of the I part. We change the sign of the coefficients of the I. It will become conjugate. And then next alert, the thing that I mentioned just now. In these equations here, these two terms I highlight is a case of square root of negative number. So before you do anything further for the calculations, please kindly convert these two into I form first before you go for further calculations. So let us have a quick review on the answer here. What is square root of negative 4 actually? It is actually square root of 4 multiply square root of negative 1. The idea is just as simple as you always break it become something multiplied with square root of minus 1 will do. And this square root of minus 1 will turn to become I. Square root of 4 is 2. So square root of negative 4 is 2i. Similar idea. Square root of negative 9 is square root of 9 multiplied square root of negative 1. So square root of 9 is 3. Square root of minus 1 is I. So I is square root of minus 1. So this is the conversions we're going to do on these two terms here. And also we substitute the conjugate of z to proceed our calculation. So as a result, begin from the equations given. Substitute the conjugate of z, which is x minus yi. Watch out. X plus yi is z. Now we want conjugate. So conjugate, change the sign on the I part. Substitute square root of negative 4 become 2i. Substitute square root of negative 9 become 3i. We substitute the I term first. Substitute the square root of negative term first become I. Then only we try to simplify our equations. So let us try to simplify the term inside the brackets. As we can see inside the bracket, we have two items there. 3i minus 5i. I suppose if you give me the result as 2i, negative 2i. And then the left-hand side is still maintain the same, x minus yi. Next, what we do is that we multiply 2i inside the brackets. So I have 8i minus 4i squared. In here, if I is equals to square root of minus 1, I squared will equals to negative 1. So 4i squared, it will equals to negative 4. So as a result, these numbers here is actually negative 4. So if you minus negative 4, later it will turn out to become plus 4 lah. So in here, my calculation, I substitute the I square become minus 1. So when the time I multiply it later, I will have 4 plus 8i. And now, watch out, compare real with real. I have x equals to 4. Compare imaginary, which is the coefficient for I and the coefficient of I find out that I have y equals to negative 8. Because originally you compare is negative y equals to 8. So therefore rearrange y equals to negative 8. There goes the answer. So in this question here, it tests us the very basic knowledge on the conversions of items from square root of negative number, and also the idea on how to determine conjugate. So 5 marks for this chapter 1 here. Go on. Question number 2. 11 marks is allocated to us, and it regards on chapter 2. So in here, the first question given to us is to solve the equations of 9 power of x minus 11 equals to 2 multiply 3 power of x plus 1 plus 8. So when the time you look at this equation, obviously somehow like this is regards on the case of indices equations. And how we solve that, later we try to tackle it slowly. B, we have the case that we want to solve an inequalities. And the final answer that we need to achieve is in set notation, as you can see the keyword set here. And this inequality is the case of with two different modulus. And by right, the strategy to solve is by squaring both sides. But be aware, it's a bit unusual for this question here, where it have extra conditions behind. Later, your solution for the inequality, you need to take notes on this extra condition where x shall not equal to negative 3 over 2. You need to consider this. So now, we go on with the part A questions. Solve the equations. So as we can see, this is the case of indices equation. So let us identify where do we have the index terms. So we have 9x and 3 power of x plus 1. So when the time you identify the indices term, and if you realize the base number is not the same. If the base number is not the same, the first thing come into our mind is that, is it possible that we can change them to the same base number? The clue usually is something like this. we try to change it to the same base number if possible. And then later we further think what else the strategies we can do in order to solve the questions. We find out that 9, 3. 9 is actually equals to 3 squared. If 9 to the power of x is actually 3 to the power of 2x. So it can change to the same base number. Then if you can change to the same base number, we realize that the power of the terms we have is happen to be 2x and also x. So there are two times of each, the 2x is two times of x. The power here is two times of the other. So I suppose this is the case that we're going to solve by using the quadratic case of the indices equations. And in order to have better view, later we're going to do substitutions on 3 power of x. And before we can do anything or further on the substitutions, let us do some adjustment in the calculation here before we can solve by using quadratic way, where the adjustment I want to make here is that first, of course, change the base number 9 here become base number of 3. Then the base number 3 here with power of x plus 1. Let us get rid of this plus 1 here by using the rules of indices, where let's say I have a to the power of m plus n. It is actually a power of m multiply a power of n. And therefore now convert 9 to the power of x become 3 to the power of 3, 2x as we see just now. Constant negative 11 maintain. Then this part here, what we have is that, okay, let's see. Let us try to expand the 2. At the same time, we also convert this 3 power of x plus 1 become 3 multiply with 3 power of x. Expand 2 with 8, I have 16. Then the next slide, we can further simplify in the way that the 2 and 3 here, we can multiply become 6. And also, we try to bring all the terms to the left-hand side. And as a result, this is what we have. 3 power of 2x, negative 6 times 3 power of x, negative 27 equal to 0. Then we make assumptions to do substitutions. Substitution, although it's not compulsory, but it is a good way for us to see things in a much simpler form. So we let y equals to 3 power of x. If you don't like to use y, you can use some other letter which is not being used in the questions here and not commonly used by mathematics. For example, you don't use exponent, you don't use e for exponent, you don't use pi for pi 3.14 something value. So you can use, let's say m, you can let's say u, whichever again doesn't contradict with the question or some of the mathematical notations. So in here, if y equals to 3 power of x, y squared will be 3 power of 2x. And as a result, the whole equation now become a much simpler form to see. Y squared minus 6y minus 27 equal to 0. To solve this quadratic equation, I solve it using the classic way, where I do factorizations. I get y plus 3, y minus 9 equal to 0. Then proceed. You find out that from each of the factors, it gives us a result y equals to minus 3 or y equals to 9. We have two possible answers, and we need to decide which one should we accept or which one should we reject. But before that, before you do any decision, please, whether you want to reject a certain answer, you don't reject when the type is still written in y in our assumption, in our assumption term. So let us replace back the y here first, become 3 power of x, 3 power of x. And you find out that in the first case here, 3 power of x equals to negative 3. In this case here, we're going to reject because there's no solution. As a positive number, no matter how you power it, it will never ever get negative answer. So we reject this value as 3 power of x is always greater than 0 for all the x which is real number. On the other side, we notice that 9 we can convert to the same base number 3. So I have 9 is 3 square. By comparing the power on both sides, now we have x equals to 2. And there goes the answer for this equation. There's only one x value, fulfill these equations. Go on B. Let us try to solve these inequalities here. The case of absolute inequalities, we have two different modulus terms. Okay. So the strategy to solve, yes, is square both sides, but guys and girls, please make sure you square with a proper concept. Some of you, you may square with a wrong concept, but yet you get the correct answer. For example, what is a wrong concept of squaring both sides is that some of the students, they happen to do squaring both sides in the way that they as if like misunderstood, where they consider each of the terms that I highlight here separately, you're going to square them separately, which is means that in your calculation later, you're squaring both sides, you consider as you square like this. And obviously, this is a wrong way of squaring both sides. This is not proper. Although the final answer you get is the same, but it doesn't proceed from this original equation direct to here. Consider as squaring both sides. This is not proper. And if you realize that whenever you solve absolute inequalities or even equation, whenever you deal with modulus, there is a certain formation that we need to fulfill first, certain arrangement that we need to fulfill first before we try to use any of the strategy to solve it. So in this case here, it's a formation that we want is that when the time you have two different type of modulus, we're going to rearrange it in the way that one modulus on each side, then only we start to do squaring both sides. And please be aware when the time you do squaring both sides is considered everything on the left and everything on the right being squared. So when the time you square, the two that multiply with modulus, you need to square it as well as what I have in the next line. Inequality sign maintain unchanged, still less than. Expand the square, this is the result that we have. 2 square become 4, and then 3x minus 2 squared become the following result. And how I get this answer here instantly, recall on the formula. If let's say m plus n equals to m squared plus 2mn plus n squared. If the case of minus being square, so we m squared minus 2mn plus n squared. This is how I can get the answer quick enough in one line. Then next, let us expand the 4 on the left inside the brackets. Expand the 4 on the left. The right maintain the same. Now you're supposed to see that you have a quadratic inequalities. Rearrange it. You have 7x squared plus 60x plus 32 less than equal to 0. And to solve this quadratic inequality, I'm using the classic way that I'm going to do factorizations. Then I try to sketch graph. With the quadratics expressions here, where the x squared come with positive coefficient, I suppose when the time I solve with graphical method, I have the graph happen in a smiling face graph. And the x-intercept here, how I'll obtain the value, refer to each of the factors here to find out what are the value that make each of these factors here become 0. That will be our x-intercept. And I find out that the first bracket is minus 4 over 7. The second bracket is negative 8. Arrange them according to ascending order. So I suppose I have negative 8 followed by negative 4 over 7. And since we're asking for the case of less than 0 for the graph positions here, it will be referred to these locations here of the graph. And the corresponding x value that we want is this part here as I highlighted in yellow. So this is the graph, and please be aware, how come that one extra dotted line here happens in my drawing here is because the condition that you may have forgotten after you're so excited to do the calculations, where the question say that your x shall not equal to negative 2 over 3. And negative 2 over 3 is happen to be within the regions that I shade. So here is the position of negative 3 over 2. I need to exclude this value from my solution. So with this dotted line interfere on the shaded regions, so you can see now I can have two interval, and these two interval we're going to union them as our final answer. These two interval is happen to be separated by the value of negative 3 over 2. So see, originally lah, from the graphical methods, you're supposed to get this as the solutions. But the question gives us the condition that we shall not having x is negative 3 over 2, where negative 3 over 2 is within this interval here. And as a result from the diagram, I suppose you can see that if I exclude negative 3 over 2 in interval notation, I suppose I have negative 8 close brackets to negative 3 over 2 close brackets, sorry, open bracket, not supposed to close here because cannot include negative 3 over 2, union, negative 3 over 2, comma, negative 4 over 7, close bracket. But watch out, this answer here is interval notation. The question asks for the sets of values, so I need to put in set notations. So the set notation start with the curly bracket x, which is the variable in the questions, dot dot, the first inequalities on this part here, then followed by the second inequalities. And in between these two inequality inside the curly bracket, it will be the case of or corresponding to the unions notation. And inside here, you shall not use the union notation inside the bracket. You shall not use comma. It's not appropriate. Union is for the whole set outside the curly bracket. Then yes, we may have union situations for further calculations. But if let's say within the brackets in here, you shall not have the union notation. It's not appropriate. So this is how we get the answer for these questions here on chapter 2. Okay. By the way, if you realize in my solution here, I didn't keep on writing x not equals to negative 2 over 3 along all the calculations here. Like what happened in my lecture previously or in my tutorial, I asked you all to keep writing these conditions here all the way at the side to remind yourself that the x shall not equal to negative 3 over 2 until the final decision to determine answer, because I want you to always remember that this condition is important. But in actual fact, during the exam, right, you don't have to write down in every single step. You just need to make sure at a certain moment before the final answer, you think of it, you remember it, and then consider it before you have your final answer. Like what happened in my diagram here. I remember that it shall not include negative 3 over 2. So I consider in my diagram. And then from there, I further go for my answer. Continue. Next, we go for question number 3. This questions here is dealing with chapter 5, function and graph. So the questions given to us is that we have a piecewise function fx defined by a quadratic functions and also a linear functions for the corresponding inequalities or interval of x less than 1 and x greater than 1. So the question asks us to find out what is the function value when the time x is equal to 0 and also 3. So in other words, in this question here, they ask you to find what is f0, what is f3. After we have this done, they ask us to sketch graph. So by right, just quadratic and linear, you're supposed to able to sketch it. Furthermore, the quadratic is written in the form like already completing the square. So it should be much easier for us to determine the shape later. Then finally, state the range. The word state here tell you that no calculation is required to be displayed. You can just write down the answer. So now we start with our calculations here for part A. Find the answer for fx when the time x equal to 0. So to calculate when the time x is equal to 0, which is f0, I should substitute 0 into which functions. So you need to check for the condition, the inequalities here. 0 located in which interval? And I suppose 0 located in the first interval, which is less than 1. So we're going to substitute 0 into the first function. So the x here term becomes 0. I will have negative 1 square plus 2. And it will give me the answer equals to, sorry, the answer should be equals to 3. Then next, when the time I would like to calculate when x equals to 3, which is f3, I would like to substitute 3 inside the function. And which function should I choose? Guys and girls, don't do blind guess like as if like, oh, just now use the first function, the next one must use second. Or blind guess to say that just now use first, now also use first. So please don't do blind guess like that, but we really going to think mathematically to decide the answer, where again we refer to the inequalities here, the interval here. If 3 is belong to the situations of greater than 1, so we use the second functions for calculations in this case here. So we have the answer 3 minus 3, which is 0. And if you realize you combine the x value and the function value, you got the point of 0, 3, you got the point of 3, 0. And the 0, 3 here is actually the y-intercept of the graph. That will be very useful later in graph sketching. Here is actually the x-intercept for the graph. And now we further go for the graph sketchings. Okay, guys and girls, when the time you do graph sketchings for piecewise functions, I will suggest that you get ready a rough sketch using start with the x-axis first, and then consider inside the interval here, those value you see in the interval here will be the borderline, and in here we see 1, so I should have a borderline of 1. The borderline here I do dot 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 is trying to tell you that the function on the left and on the right of this dotted line, it will be different functions, where in this case here on the left it will follow the first function, which is the quadratic. The right will be followed linear. So we have one curve and one straight line. And by the time you draw piecewise function, I will suggest that you try to tackle the curve first, so that after you're able to draw the curve nicely inside the diagram, then only you adjust the straight line accordingly. If you draw the straight line first, then you need to consider draw the curve and also at the same time try to adjust with the straight line, which is much difficult. So in here, let us try to consider how to sketch this quadratic here, which is already in the completing square form. First of all, we realize that the shape of the curve here is happen to be a smiling face graph because I have positive coefficient for x squared. If this is a smiling face curve, by right, there is an important point, which is the minimum point. And how I get the coordinate of minimum point? Take this position here in the completing the square, make it equal to 0. So we have x minus 1 equal to 0, x equals to 1. It gives us the x coordinates. Then the y coordinate, we just take this constant, 2. If you don't believe that y we get the 2, try to substitute 1 inside the function back. By right, you should get the answer of 2. If you substitute back the 1 back inside to these functions. So reach up to here. This is the full graph of the quadratic from infinity to infinity. However, if you read the questions carefully, they are not asking from infinity to infinity. They're asking for the case of less than 1. So less than 1 for x, it will refer to only the left-hand side of the graph. I only want this part of the curve. The rest of the part of the curve is not needed. So therefore, the actual part that I need for the graph is just this part. Where at this point here, I will have 1, 2. I just want this part of the curve only. So maybe in your Cartesian plane, you can start to consider if here is x equals to 1, y equals to 2, maybe somewhere here. So your graph will look something like this for the quadratics. And in here, it shall not equal, it shall not include 1, it shall not include 1 because no 1 here. In here, x is not equals to 1. Then for the linear, what you do is just that you try to do calculation using 2 points. And since the question tell you that x must be greater than 1, so you don't choose x equal to 0, substitute into this function here for calculations. So you choose the point according to this interval. So for example, you choose x equals to 1. And then in here, we choose x equals to 3. We should already have the answer on the previous part. So we find out that the corresponding y value here is, if x equals to 1, we substitute inside, we have 2, 0. Then therefore, when the time we try to sketch the graph, this point here is actually 1, 2, 1, 2 also. So from this point here, we connect until 3, 0, which is the x-intercept. And watch out, the point that just now the curve and also the straight line meet, do it happen to be connected or not? We need to check back on our inequalities for the interval. Do I have either one of them equal to 1? In this case, it doesn't. So by right, here, this part here, I should leave a hole there for the point 1, 2. Then the framework is done. We try to insert our y-axis to complete everything, and then label the y-intercept that we have found just now. And therefore, this is the answer that we should have. The red dotted line is just a guideline to see the transitions of the shape of the graph. It's not compulsory to be there. The thing important to have in your diagram is that label the xy axis, the basic thing, x and also the y and also x intercept, the transition point, and in here the point should be left with an empty circle because it's this continuous here where we have x not equals to 1. Then finally, C, they ask us to state the range of f. State the range of f, that means that if we have graph for reference, and as this case here, we try to observe from the graph, what are the y value is being covered by this graph here. And you find out that for the green graph here, the curve, it cover every single y value. Sorry, I think it's not a good idea to use the red pen here to do shading. So let's see, for the green graph here, we find out that it covers every single y value, which is possible according to the green graph. For the blue graph, it covers every single y value as I shaded here. And at the point where the green and also the blue shading meets, and this particular point here where y equals to 2, you find out that it is not included in our graph because there's a hole there. So your answer here for the range of f is supposed to be infinity to infinity, but exclude 2. Like this. There goes the answer. So therefore, this is the answer for the range of your function f is exclude 2. Continue. Question 4 in section B also regards on chapter 5. And let's see how we solve for these questions here. So these questions here dealing with quadratics. So in this paper here, there's no exponent or trigo function is being set. Maybe in some other set we'll have. So anyway, let us try to see how to solve for these questions here. You are given a quadratics functions with the condition of this quadratic here, where x is less than 1. So this condition is very important to take notes because later when the time you determine the domain, you need to consider this constraint as well as the graph sketching. You need to consider this constraint. Like just now what you have done in the piecewise function. After you have done the full graph, maybe initially, then you consider the restriction from this interval here. So now we start with the calculation on part A. They want the domain on range of the function. Again, the word state means that direct answer, no calculation is required, or you don't have to show any of your calculation there. Then next, they ask you to sketch the function of f and then show that f is a one-to-one function. So sketch graph and then hence show one-to-one. That means in here, you can only use graphical method, which is the horizontal line test only. You're not supposed to use algebraic methods at all because it's a guided question. Then next, find inverse, state the domain and range for inverse. So this is what we require to do in question 4. And now let us try to solve the questions here. Okay. So let's see. State the domain and range for function f. So for the case of quadratics, in general, you find out that in general is by right having the domain infinity to infinity. By right in general, secara umum, you have the domain as infinity to infinity. But now we have a constraint to consider. Instead of taking this answer here, we need to intersect with this result, this condition. So we find out that therefore, if intersect of this one, these two, that means our domain will happens to be negative infinity to 1 only. Then how about the range here? So if let's say you have extra conditions there, maybe for range it's not very helpful if you try to figure out by calculation where it's maybe easy for us to make mistake. So maybe I need to have a rough sketch to help us to decide the answer for the range as well as double check the answer for the domain lah. And I do this because later somehow I need this for part B as well. So I know I have a case of quadratics. If I try to expand this, I find out that I have a positive x squared, which tells us that the shape of the graph is a spiraling shape graph. And this spiraling shape graph, I have a important point, which is the minimum point. And the coordinate of this minimum point, I can obtain the x coordinate by taking the content inside here, x minus 1 equal to 0. So I have x equals to 1. This is the x coordinate. The y coordinate, just take the constant, 3. And now this is the shape of the graph and also the special point that I require to have for further determinations on the answer. So this is the full shape of the graph. However, what we want is not the full shape in general, but we want to fulfill the conditions that I shall not have it anything outside of this constraint, which is I want the graph only for the part x less than 1, which is this whole part here that I highlighted in blue. And if I extract out, it's supposed to have the graph looks like something like this. Half of the parabola, and at the point here for 1, 3, because we see there's an equal sign, so this circle here, we need to shade it. So this is the shape of the graph. Now, if based on this shape of the graph, you're trying to observe how far the graph can extend to the left, right for domain, up, down for the range. And this circle here, these dots here is trying to tell us that the graph no longer extend after this. So once we double check, the graph can extend infinitely to the left. So we have the domain is infinity to 1. It can reach maximum on 1 horizontally. Vertically, it can go up all the way to positive infinity, go down as low as the value of 3. So therefore, the range is 3 to infinity. Continue. We already have the framework of this graph here now. We can use it for the drawing in the next part here, part B. So if I notice that the important point is 1, 3, if I try to put it in a Cartesian plane, so x equals to 1, y equals to 3. So I find out that the graph will look something like this, where obviously we see that there is no x-intercept, so don't spend time to find x-intercept. But for sure there is y-intercept, so let us have a quick calculation of y-intercept by substituting x equals to 0 inside. So I suppose I have this y-intercept here equals to 4. And therefore, I can complete my graph as the following. So this is the graph I suppose I have. Then if the graph is done, check what is the important thing must be there. Again, label the XY axis, the special point 1, 3, the y-intercept, the origin 0. And then now, after you sketch the graph, it's not end of the story on part B. After sketching the graph, they ask us to show that f is a one-to-one function, as we mentioned just now. We are going to solve it by using horizontal line test. So you can try to use your ruler, put it parallel to the x-axis and slide along the line. You will see that your ruler is always cut the graph at one point. So if always cut the graph at one point, therefore we shall say that the f is a one-to-one function. So how we should solve for the question here is that first, you try to draw a horizontal line, give it a name. If you don't know how to label in a proper way, like y equals to k, then you just simply give a name like L. For example, in here, you just tell it as a line L, and then show the intersection at one point. If you're able to have the intersection at more than one point, then you stop at more than one point. If not able, you just simply put somewhere lah. Then this line here is trying to show that you don't simply make conclusion, but you are trying to do a horizontal line test to get answer. And your conclusion inverse is that by horizontal line test, f is a one-to-one functions. And if you want to have further reason, what does horizontal line test tell is we note that the horizontal line y equals to k cut the graph at only one point. So this is the observation and also the reasoning for one-to-one functions. Proceed further. C. On how to calculate the inverse. So in this calculation of calculating inverse, take notes. Again, I believe in your SPM level, maybe you used to do the technique that you let y and then you try to solve the question. But today, I don't recommend you to use let y equals to function fx or even f inverse, because the let y here, you make a lots of unnecessary mistake, and also you make it have misconception because you miss out something. So today, I would like you to try to stick with this idea here. You always consider these properties here. F composite with F inverse equal to something. And what is something here for the result? Equal to what? Depends on what you have in the bracket. If you have hashtag, so equals to hashtag. And in here, to find the inverse, I would like to have F composite F inverse equals to X, where the bracket I want X. And for this quadratic case here, it's important to take notes on one thing. According to the questions for the function of fx, you find out that the fx function here, you was told that the fx functions here, it had the condition that x must be less than equal to 1. Where what is this function talking about is that if let's say I have f hashtag, then the hashtag here should be less than equals to 1 according to these conditions. So in this case here, the hashtag is f inverse. So the f inverse should be less than equals to 1. And this criteria is very important for the case to determine inverse for these quadratic functions later. Go on. Now we proceed further. What is happening with f composite f inverse is that we try to substitute f inverse into the function of f, where all the position of the function f with x terms, we're going to substitute with inverse. As a result, this is what we have. Rearrange the equation so that we have inverse on one side, the rest on the other. So initially, I have inverse minus 1 squared equals to x minus 3. And then watch out. I would like to get rid of this square here. So for your information, let's say I have y squared equals to k. If I want from y squared become y, I need to involve of square root. And furthermore, it's not just square root, but it's the case of plus minus square roots of k. So in this case here, I should have it as plus minus square root of x minus 3. Then from there, we find out f inverse equals to 1 plus minus square root of x minus 3. However, this is not yet the final answer because take notes, because your inverse only have one function. Now in this case here, actually, you have the case of 1 plus square root, 1 minus square root. And which one's supposed to be our result? So watch out to make the decisions here, guys and girls. Maybe by the time you solve this type of question in the past year, you never ever consider to do plus minus. You only consider on plus. And coincidentally, you get the inverse correctly. Because the conditions required in the question, yes, they want to use the plus square root. But today, in these examples, I purposely set the questions to let you know the importance why I need to have plus minus. So if you realize how I determine whether I want 1 plus square root or 1 minus square root is based on the condition I tell you just now. The conditions say that your f inverse must be less than or equals to 1. So how will you decide here? By the time I have the situations where, watch out, I have 1 plus square root and I have 1 minus square root, you find out that what happened is that the square root is always a positive number. The square root is always a positive number. If 1 plus positive number, the result is always either greater than 1, or maybe the square root can be 0 as well. So 1 plus 0 or equal to 1. Similarly, the square root may be positive value or 0. So if you give me the result, if 1 minus 0, I will get 1. 1 minus some positive answer, for sure the value will be less than 1. And if minus 0, so it will be equal to 1. So these are the two scenarios I have, and which one should I choose is that the conjugation tells us that I want the inverse less than 1. So less than 1 is the case of 1 minus square root. Therefore, this is the answer that I should have for the inverse. So please be aware. And once I get the inverse, now state the domain and range. And guys and girls, by right, by the time you state the domain and range, don't just simply look at the inverse to get the domain and range, but try to recall back on the properties. Domain of inverse is equals to the range of f. The range of f inverse is equal to the domain of f. And try to see the domain and range that you observe from the function inverse itself. Is it valid for these properties or not? If it's not valid, then check back where is the part that you make mistake. So in this case here, the domain is 3 to infinity. The range is negative infinity to 1. That's it. And there goes the solution for these questions here, which is question number 4 in section B. Then we go on with question number 5 in section B. And this question, we have 13 marks on chapter 8. And if you realize chapter 8 just now, in section A, we have around 9 marks. Now we have 30 marks. In total, 22 out of 100 marks. So it's quite a lot of marks there for chapter 8. So make sure you study your chapter 8 very well. So in these questions here, you are given a piecewise function of fx defined in 3 functions for x less than c, equal to c, greater than c. And the c is a constant. Then if you were given the information, if limit x approach to fx equals to m, where m is a real number. So what does this sentence here actually tell us that? It actually tells us that the limit exists. The limit exists at x equals to c. So if limit exists, that means limit approach to c minus, it will equals to limit approach to c plus. And how does that help us to do further calculation? At this moment here, we don't know yet, but this is what we understand about the info so far. Then you was told that f is not continuous. For your information, kalau continuous, if continuous, we have 3 conditions to fulfill. But if it's not continuous, then I need to see it happened to fail in which condition. Does it happen to fail at the beginning of the first condition, or it failed in some other conditions? And let's see. You find out that in these questions here, the FC is defined. How come I know that it's defined? Because C is within the domain. So condition 1 is fulfilled. How about condition 2? Limit x approach to CFX. Does it happen to be exist or not? And the answer is yes, because it can equal to a certain real number. That means it exists. So if the question still insists that f is not continuous at C, that means the third condition is not fulfilled. Where in this case here, the third condition is fc equals to limit x approach to CFX. If this condition is not fulfilled, that means these two are not the same lah. And anyway, after I understand about all these situations here now, let us try to solve the question accordingly, where we want to find the unknown C, M, and also K. So first, I want to find the answer for C. Where is the case that I have the info of C is that I have the C at this field position that I highlight. And in order to get the answer for C here, we're going to make use of the idea that the limit exists for x approach to C. If the limit exists, that means the left hand limit and the right hand limit is the same. So limit C minus and C plus will be the same. And what is the function used for C plus and C minus according to these questions here? Let's see. For the case approach to C minus slightly less than C, that means we are using the first functions. X approach to C plus, it will be slightly greater than C, which is greater than C. I'm going to use the third functions. So as a result, we substitute accordingly. After we do our substitutions, you find out that the limits on the left hand side is a polynomial. We can just direct substitute C inside to get the following result. However, for the right hand side, if you do direct substitution, you find out that the result is 0 over 0. So there must be some linear factors, the same linear factor top and bottom that creating 0, we need to cancel it off. And in order to do that, usually it evolves of a linear factors. So I need to factorize the quadratic and also define the modulus. And let's see how we define the modulus. When the time I have modulus y equals to k, it will happen to be defined in the way of positive k for k greater than 0, minus k for k is less than 0. Equal 0 is not discussed here because by right, you cannot have it equal to 0. Now what if the y now is c minus x? What happened now is that I have the result. Sorry, I'm not supposed to have the k here. I should have y only, y and minus y. So I have c minus x for the case of c minus x greater than 0, negative c minus x for c minus x less than 0. And if I try to simplify the inequalities, this one become x less than c, the one bottom x greater than c. And this term here, there is an alternative way to write it will be x minus c. And which one shall we choose according to this question here? We have c plus, that means slightly greater than c. I'm going to choose for the second functions in this modulus. And as a result, factorize and choose the appropriate functions for the modulus. This is what we have. And we can see that the factor creating 0, x minus c is there, top and bottom. Let us cancel it, have the result. And at the same time, the left-hand side, I'm able to simplify it to get answer as 4, because in here, I have c squared minus c squared. Now, this limit here is in polynomial. I can substitute the c for direct substitution to get answer. So 4 equals to c plus c, 2c equals to 4, c equals to 2. There goes the answer. And once you get the answer for c, now the piecewise function have made some changes, where we have all the information here in the question now, all the part c there, all the terms with c there, we can replace with the value of 2. After we have find out c equals to 2. And now let us try to find out what is the answer for This one's supposed to be m, not 2. Check back. It's supposed to be m. The one supposed to be equals to 2 is this value here. Limit x approach to 2 equals to m. Now, how should we get the answer for m, and where is the m located at? Which is happen to be located at the limit x approach to 2 for the function. So if I'm able to find out this answer here, then I'm able to get the result of m. And if you realize lah, if this limits x approach to 2 exists, that means I have the situation that limit x approach to 2 minus equals to limit x approach to 2 plus, and also it will equals to limit x approach to 2. So in other words, limit x approach to 2, I can substitute whether on the left or right hand, the left hand side limit or the right hand side limits. I can substitute with either the one-sided limit where they have the equivalent value, they have the same figures. So in order to get the answer of m, I realized that limit x approach to fx is equals to limit x approach to 2 minus. And why I choose the 2 minus instead of 2 plus is because 2 minus is a polynomial. It's much easier for calculations. You nak choose 2 plus the third function, pakai the third function pun tak salah. Tapi you perlu budget lebih masa lah untuk buat kiraan. So that's why I take 2 minus. As we see the properties here, the two are the same. So limit x approach to 2 according to the question is m. Calculate limit x approach to 2 minus fx, which is I substitute 2 into the functions, the first functions. So I will have the result m equals to 4. So there goes the answer for m. Then lastly, C. What is the answer for what's the answer in C? Or C, check back. I think I made a mistake there in my questions. C, I suppose that I need to find out what is the value of K. And in here, you see, not just value, they want the sets of value. That means it have more than one value for K and need to be expressed in set notations. And let's see how we get our answer here. As we say just now, if let's say function is not continuous at x equals to 2, and we find out that it fulfill the conditions for f2 is defined according to the questions here, condition number 1 is fulfilled. Condition number 2, limit x approach to 2 exists, also fulfilled. The only thing that not fulfilled is the third condition. So if the third condition is not fulfilled, that means that I will have the first and second condition, they are not equal to each other. F2 is not equal to limit x approach to 2. And what is F2 and what is limit x approach to 2? In order for us to calculate out the answer for K, F2, we substitute 2 inside the function. In this case here is a constant function, K plus 3. So F2 is K plus 3. Limit x approach to 2 for fx already we find out in our calculation just now. Again, I think I made a mistake here. Here's supposed to be m. The other part here is supposed to be 2. And just now we find out m is actually equals to 4 in part B. So by right, the limit here is equals to 4. And we find out that k is not equals to 1. And this is not the final answer that required because the question asks the set of k value. So I need to write in set notations. And how we write the set notation is that now we discuss about the unknown k. So if we have k dot dot, what is the condition for k? The condition for k is that k shall not equals to 1. So this is a set notation that we need. So there goes the solutions we have for these questions here for section B, question number 5. Then now we go on further for section B, question number 6, the second last questions. The marks allocated is 16. If add on with just now in section A, we have another 9 marks also. for chapter 9. So chapter 9, we have 25 marks, a quarter of the overall score. And these chapters here is dealing with differentiation. And what is differentiation that we need to discuss here? Let's see. Part A, by using power rules, find these differentiations. So I hope that you don't get confused on this notation here. We have dx, that means that differentiate with respect to x for this function here. Previously, you have dy dx, right? This actually means that differentiate with respect to x for the subject y. And because the subject is very simple, just y, we just write dy dx. But now the subject is square root of 1 plus x squared. And let us see how we get the answer. Then after you get this thing here done, you was told that you're given this function here, which is an implicit function. They ask us to, part 1, with this condition not equal to 0, we're able to show this dy dx. And already at this moment here, we have no idea what is this condition about. What does it help? But never mind. The show that tell us that somehow you must find first derivative from here to get this answer. Maybe along the calculation to get this answer, you see the use of this condition. Hence, show that we have this equation involve a second derivative. The word hence means that must make use of previous result. That means must make use of this first derivative to get the answer. And let's see how we solve for each of the parts. Part A, by using power rules. So we want to differentiate this subject here. The subject is in square root form, which is not so convenient for differentiation. So I would like to convert it into indices form. And before we go on further, recall on how to do differentiation by power rules. So if you differentiate with respect to x for a function hashtag power of n, by power rules, it will be multiply the power to the front of the brackets, power reduced by 1, multiply with the differentiations on the hashtag, which is the bracket terms. So in here, what you see for the calculation is that bring the power to the front, 1 over 2, bracket terms maintain, but the power reduced by 1, 1 over 2 minus 1, we have negative 1 over 2. Then finally, this last part here, differentiate the bracket terms. So we have 2x. And now simplify your answer. You will find out that constant 2 can simplify. Power of minus 1 over 2 will turn out to become, let's see, if I try to simplify, power of negative 1 over 2 will turn out to become 1 plus x squared, power 1 over 2 at the bottom. 2x multiply 1 over 2, I will left x on top. And this one is actually equivalent with x over square root of 1 plus x squared. So there goes your answer by power rules. Go on. B. Now we want to go on with the calculations of implicit differentiations. So what is implicit differentiation do is that we're going to differentiate each of these terms here with respect with some unknown. And in this case here, because you see the final answer you want to achieve is dy dx, that means you want to differentiate with respect to x for each of the term. By right, just x squared you can differentiate easily. But the second part here, watch out. You have 2y multiplied with square root of x squared. So this one you need to do product rules where you need to have to consider u, v. So later you need to differentiate u and differentiate v in order to proceed with the product rules answer, where you find out that by product rules, if you differentiate with respect to x for u, v, the result will be u, v prime plus v, u prime. So now, let us have a look on the result. Differentiate x squared, I will have 2x. Okay. Watch out for these differentiations here. I'm going to write down the step first before I show you the tab solutions. So we have negative in front, so I keep the negative outside, a big brackets. Inside the bracket, we will do product rules on these two terms here that I highlight just now. So u, v prime, so we maintain u. We differentiates with square root of 1 plus x squared, and then we plus with maintain the square root of 1 plus x squared, and then we differentiate the 2y. So I suppose I have 2 dy dx. And if you observe, these differentiations here, you're supposed to be very familiar with it, which is actually the result that we have just now, this one. So actually part A guide us to get the differentiation on some of the part that we have in part B. And you can just directly apply the result, ambil saja result dia untuk kiraan. So therefore, now the product rules, I suppose this is what I have lah. Okay. Once again, if you're not clear enough what is going on in these differentiations here, let me highlight the parts. Let me highlight the parts here. Maybe I use another color. Let me highlight the parts here in green. This is the result of the differentiation. And how I get this result here, let me write back step by step. Okay. So I suppose that I consider this whole thing here become negative brackets, as I mentioned just now. So you can add this step here if it's not clear enough for you. So we have the differentiation become 2y multiply with differentiations with respect to x for square root of 1 plus x squared plus with maintain the square root 1 plus x squared. Then we differentiate with respect to x for 2y. And what we have for the result inside the brackets here, let's check. 2y, and you find out this term here now I highlighted in pink can actually get the result of the differentiation from our previous calculations. So I just plug in the result only. I don't have to go through all the calculation process anymore. And therefore, this part here is multiplied with x over square root of 1 plus x squared plus with square root of 1 plus x squared multiply with differentiate 2y, I have 2 dy dx. Then from here, we simplify our answer. You find out that we have minus 2xy over square root of 1 plus x squared plus 2 times of square root 1 plus x squared dy dx. And expand the negative sign, you got this result here in green. You got this result here in green. So this is how we happen to have our result. Then not yet finished. Differentiate constant 3, I suppose you have 0. Minus differentiate y squared, I suppose I have 2y dy dx. By write the 0, you don't have to write. So you just have negative 2 dy dx. At this moment here, differentiation process is done. We just need to rearrange all the terms there so that we can get the final answer dy dx as this result here. And in this result here, as you can see, there's no y term there. So maybe there is some way that we can get rid of the y term there. And maybe this condition is the clue for us to do so. So next, what we do is that let us gather all the dy dx term on one side. Let's say I gather it, let's say I gather it all on the left-hand side. But before that, if you find out each of these terms here I underline, we have a common factors of 2. Let us divide by 2 first before we rearrange. Because maybe sometimes that we are too excited to rearrange, forgot about dividing with 2 to simplify the functions. This happened like just now what I tried to do. I'm so excited to rearrange first. So by right, I check common factors. If there is, simplify it. So we divide by 2. So this is the result after we divide it by 2 for each of the terms. And now gather all the dy dx term on one side. So this is what we have. The rest on the other. So just have a quick look. What is the dy dx term that we have, which is this dy dx term? We group it on the left. The rest of the term, let me highlight it in yellow. We rearrange on the right. And then next what we do is that on the left, we factorize the dy dx. And then by right later, we will rearrange these terms here. And in order to have it easier or better way to do the rearrangement, the one highlighted in yellow on the right hand side, let us convert it into a single fraction form. So let me write some extra step here so that you have a better idea how it go to the next line. Where I would like to have this x here come with the denominator of square root of x squared. So I suppose to have x minus square root of 1 plus x squared over square root of 1 plus x squared. And then the xy as usual, square root of 1 plus x squared. So by right, I can join both of them together in one single fraction like this. I reach up to here, I find out that I have a common factors of x. I can factorize. So therefore, the next time it happens that I factorize the x. Reach up to here, if you realize, the left hand side and the right hand side, both I have this term here. And are we allowed to do cancellation on that on both sides? Usually you will be you all will have no hesitation, just cancel. But actually we don't simply cancel. You can only cancel the value on both sides with the condition if both of them is not equal to 0. These two highlighted part in green, if they're not equal to 0, then only we can do cancellations. And you are so lucky. And finally, you know what's the reason they give us these conditions. They try to tell us that if you meet these terms here on both sides, you can do cancellations. And therefore, we have done the proving as follow, shown. Okay, continue. Part 2, hence show this result of the equations where evolve of second derivative. So hence make use of the first derivative to get this equation. As you can see, this equation has second derivative. That means that this first derivative, I need to differentiate once again in order to get the answer of the second derivative. And let's see the framework on how to do these differentiations here. So if I differentiate both sides with respect to x, I need to go through quotient rule. Recall back on quotient rule. The framework of quotient rule is, let's say I have u divided by v. By quotient rule, I have the answer v squared at the bottom, v multiply u prime minus u multiply v prime. So on top is the u, bottom is the v. So let's check the framework. If I, according to this formula for the differentiation, I should have second derivative. When the time you differentiate first, you get second. By quotient rule, denominator, I will have it as square root of 1 plus x squared. This whole thing here is being squared. On top, maintain the v, which is the square root 1 plus x squared. Then this thing here, we multiply with the differentiations of u. The u is x, so differentiate become 1. Minus, okay, wash out, maintain u. Multiply with the differentiations of the v, which is the subject square root of 1 plus x squared. And once again, this thing here looks so familiar to us. And if you realize, this is actually the result that we have from part A. We just again adapt this result here for our further calculations. So therefore, now this quotient rule for the differentiations can be actually simplified as the following. Where this highlighted part, we just apply previous result. And then the denominator, we square it. This is the answer. So further simplify, you find out that this is what we have for top and bottom. Again, I put a brackets there for the smaller fraction on top so that you can see which fraction is within another clearly. Reach up to here. The next thing what I want to do is that I would like to make sure that I can achieve in this form here. So maybe I try to simplify these terms here. First, to see the clue. And what is the thing that I need to simplify here is that, Let us get rid of these situations here where we have a smaller fraction within larger fractions. In order to achieve that, I would like to multiply top and bottom with square root of 1 plus x squared, which is this whole thing here, which is actually equals to 1. So this is why out of sudden why you can multiply something and yet all the calculation is valid. The result is still consistent because you're actually multiplying 1. So with this multiplication, what you happens to find out is that let us highlight the terms and we check as comparison the purple, the blue, and also the red. And let's see what's the changes happen to them. So by the time you multiply on top, you find out that you have the result for the one highlighted in purple. The same square root term multiplied itself, so the square root term is gone. For the one in blue, the denominator is gone. Then for the one highlighted in red, you find out that you have the case of now, it will become power of 3 over 2. And how it come power of 3 over 2? Let us try to again observe. These two terms when the time multiply is 1 plus x squared multiply with square root of 1 plus x squared, which is power of 1 multiply with of 1 over 2. So at last we have 1 plus x squared power of 3 over 2. Then next, what we do further in our calculation is that we rearrange our equations where by right, the left hand side, you have second derivative, right? We can rearrange this term here to the other side to simplify our answer. But before that, let us simplify the terms on top, the purple and the blue. It can simplify become 1 only because the x squared minus x squared itself. The rest, let's say, maintain the same. Now, finally, we try to rearrange this one to the other side. So we are almost there for the answer. As you can see, we're almost there. And now, how does this convert to the form that we require is that if you realize, when the time you have, let's say hashtag to the power of 3 over 2, this is actually equivalent to either you can write it in the form of square root of hashtag, the whole thing power of 3, or maybe you can write it as square root of hashtag power of 3. Either one will do. So as a result now, I can convert my answer as the following to fulfill the requirement of the questions, which is this form here. And this equation is the one that we want to show. So we have ended proving here. Finally, the very last question on this paper here, question number 7, regards on the applications of differentiation. In this case here, we discuss about the rate of change. Okay. So there's some story there. A lot of words is written there. Let us try to understand the story there. So the diagram below shows a jet flying at a constant altitude. Constant altitude means that if flying in the same height, it doesn't move up and down at a constant speed. So if fly in a constant speed, it doesn't suddenly become accelerated. It's just like fly constant speed with 1,200 kilometer per hours. While it's not a missile, it's actually a missile is being fired. This is the missile. It's fired straight on a straight line perpendicular to the flying path. So, and this missile here will hit the jet at point P. And all the story here is being summarized in the diagram here, where you find out that the jet is flying smoothly in the constant altitude. That means it will fly as if like a straight line. It doesn't move up, down, but it flying straight in the straight altitude. And of course lah, Why is considered as a straight line? Because I believe the jet it won't fly like this way here on the same altitude. So it's supposed to be fly in straight line on the same altitude. So therefore it's a straight line here. And then by right, let's say like when the time happened to be flying forwards and a missile is being shot in a straight line, perpendicular to the path. The dotted line here on top is the path of the jet. And by right, this missile here will hit the jet at this particular point. And you don't have to consider why the jet doesn't fly away and get hit. Is there any anti-missile equipment inside the jet? That is not in the consideration in the question. We just based on the question say that it will hit at P no matter what. With this situation here, it fly in a constant altitude like this. And then the question further have definitions to consider. X is the distance of the jet from point P. So therefore, this part here is the distance X. Then Y is the distance of the missile from point P. So this is Y. And these two distance here is not fixed. It will change from time to time. And in fact, if you realize, this distance here will reduce from time to another time. And then what is R here? R is the distance between the missile and jet. Now what you need to do is that based on this info of x, y, r here, show that the dr dt is equal to the following equation. And then B, at a certain instant, we want to find out what is the rate of change of the distance between the missile and also the jet. And the next part here, B, is actually ask you to find the rate of change, which is dr dt. So in other words, if let's say you fail to find A, you fail to prove A, you can still try your luck to use this result here to solve for part B. So let's see. Let us try to see how to solve for part A here to show that dr dt is equal to the following. So as you can see on the screen now, the diagram, I redraw the diagrams that we have originally into a much simpler form and being drawn in terms of a right angle triangle with the side of x, y, and also r according to the informations. And as you can see here, this is a right angle triangle. And I can make use of Pythagoras theorem to help me to solve the questions. And in here, since I want to find the rate of change of R, so let me try to solve this question in the way that let me write R in terms of X and also Y. And by Pythagoras theorem, I noticed that R is a distance. So R is actually equal to square root of X squared plus Y squared. If this equation, I square them both sides, so I have R squared equals to X squared plus Y squared. The reason why I want to square them both sides so that it will be much easier for me to differentiate after I get rid of the square roots. Then now, in here, a bit different from what you have done previously in the chain rule, where in the applications of questions in rate of change that you need to apply chain rule. In here, we don't really go through that I multiply two rate to get the answer that we want, but instead from these equations here, we directly derive the thing that we want, the rate of change that we want, where in here, we directly differentiate each of these x, y, and also r with respect to t. So each of these terms here, we are actually undergo implicit differentiation where r squared differentiate with respect to t, I have 2r dr dt, x squared 2x dx dt, y squared 2y dy dt. And then you see each of the terms here, we have common factors of 2. Let us divide 2. And now you can roughly see you as if have a formula now. dr dt in terms of dx dt and dy dt. And you compare back the equation that you want to show, it seems like you're almost there for the answer. So let us go on further, rearrange the term, get rid of this r here. So we multiply 1 over r on both sides, or we say we divide r on both sides. This is what we have for the result. And reach up to here, if you try to compare the answer that you want to achieve, the difference is this part here. is still in 1 over r. And if you realize the r here, we can substitute this one to achieve the answer that we want to show. That's it. So we have done the proving shown. Go on. Now to find the rate of change of the distance between the missile and the jet, which is I want to find what is the answer of the RDT and what at what moment, at what instant uh I need to consider in these questions here for part B. Let's see. So we need to consider at the instant that if let's say I have the jet is 1.5 meter from point P. So this is actually regards on the x value. We have 1.5 kilometer and the missile is 2 kilometer from point P. So in here we have 2 kilometers. And you was told that the missile is flying at the speed of 3,000 kilometer per hour. So it is flying up with this speed here. It's moving at this speed here. Where this is actually the dy dt, the rate of change of the y. So with the info so far, we find out that we can calculate the answer by substituting the x, substituting the y, substitute the dy dt, and we're still missing dx dt. What is dx dt? The rate of change of the distance between the jet at this point P here, the dx dt. And if you realize this value here is actually, the dx dt is actually speed of the plane, dx dt. Now by right, you have all the information here to plug in into the equations that we have in part A to get the answer easily. So therefore, this is the result we have after we substitute all the info that we require. So in here, watch out. How come, there's a negative sign on 1,200 and 3,000 here, which regard on the speed of the jet and also the speed of the missile. Because once again, the x and y is defined as the distance between the jet and point P, the distance between the missile and point P. And as times go on, you find out that the distance between the point P and the missile, as well as the distance between point P and the jet, is getting smaller and smaller. It's keep on decreasing. That's why the rate of change is minus here. And therefore, we calculate out our answer. I have our DRDT is negative 3,120 kilometer per hour. And this value here tell us another info where we find out that as the missile and also the jet moving towards to the point P, the value of R here, the distance between them is also decreasing accordingly. So therefore, this is the answer that we should have for the question B. And therefore, these are all the solutions we have discussed for this set practice here today. So thank you very much for watching. And now I would like to end the recording here for the discussions here. Goodbye.